Programming by example has become an increasingly popular component in software development tools, human-robot interaction, and end-user programming. The user gives the system one or more examples of an input and an output for a program they have in mind, and the system returns one or more candidate programs that would return the same outputs for those inputs. The user can then select one of the candidates, or think of more examples to add that hopefully would help the computer guess the program, or a sufficiently equivalent program, that was in the user's head. It's not an easy task for the human to pick examples that help their non-human collaborator in this exercise, the computer, guess the right program. There are a lot of reasons for this. The computer is not another human being, whose thought processes we can easily imagine, with a shared context we can assume. It's also cognitively effortful for the human to analyze the input space and how that maps to the outputs they want, and which small set of examples most fully specifies what they want. A handful of examples, which is all the human ever really wants to come up with, can be generalized into a program in many different ways. And finally, regardless whether the user is an experienced programmer or an inexperienced end user, programs can be difficult to read and are definitely effortful to mentally apply to current and hypothetical future inputs. In this work, we demonstrate how a new interface between the human and the computer can address the latter three challenges.
Our key insight is that it's more natural for users to clarify their intent on top of the original examples they give, rather than inspecting and annotating the programs synthesized by a foreign PBE system. We call this interaction model as interacting with augmented examples. Our model provides two types of augmentations on user-provided examples. Semantic augmentation allows users to specify how their examples should be generalized by the synthesizer. They can mark some characters as literal, so the synthesizer will treat these characters verbatim. They can also mark some characters to a character family, like digits, so the synthesizer will generalize those characters to the specified character family. Data augmentation allows users to ask for additional input-output examples from the synthesizer to help them understand and validate the behavior of a synthesized program. They can also compare and contrast the behavior of two similar programs by soliciting some distinguishing examples. We implement and demonstrate this interaction model in the domain of regular expressions because 1. Regular expression is a popular mechanism for text processing and data wrangling, and 2. It is often considered hard to master even for experienced programmers. The basic synthesis algorithm performs a top-down enumerative search. It starts from an empty program and keeps expanding it following the DSL grammar to compose different kinds of programs. If a user marks a letter A as a literal, the synthesizer will prioritize A when composing programs instead of generalizing A to any letter. To automatically generate additional inputs, we first convert a regex to a deterministic finite automaton, or DFA. By traversing this DFA, we can generate all kinds of strings accepted by the regex. We also convert the regex to the complement of its DFA and use the same algorithm to systematically generate negative examples that are rejected by the regex. A user study with 12 students showed that when interacting with augmented examples, all participants finish tasks with an average of 3.3 synthesis iterations. In contrast, when participants can only manually add counterexamples and regular expression annotations, only 4 participants finish the task with significantly more synthesis iterations. Participants feel twice more confident in the synthesis result, as well as less mental demand and frustration when interacting with augmented examples. We also did a case study with 20 regex tasks asked in Stack Overflow and demonstrated that our interaction model can be used to solve various realistic tasks effectively. In summary, we proposed this new idea of interacting with augmented examples and demonstrated its feasibility and usefulness in the regular expression domain. Through a user study, we showed that participants found it much easier and felt more confident to guide a synthesizer with augmented examples.